Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Formative exercise 6.6. Number 1. Solve each of the following trigonometric equations for the x from 0 to 360 degree. A. 2 times of cosine x minus 10 equals to negative 1. So first, we move the 2 to the right hand side, become negative 1 over 2. So cosine x minus 10 degree is negative 1 over 2. Look for the reference angle of the x minus 10 degree, we get 60 degree. So cosine is negative in second quadrant and third quadrant. So our reference angle of 60 degree put in second quadrant and third quadrant, and we get our angle 120 degree and 240 degree for x minus 10 degree. So the x will be 130 degree and 250 degree. B. Tangent square equals to secant x plus 2. So first, we change the tangent square into secant square x minus 1. So secant square x minus 1 equals to secant x plus 2. So we have a single function of quadratic, single unknown of quadratic equation. So secant square x minus secant x minus 3 equals to 0, and we find that this cannot be factorized. Therefore, we put in formula, okay, quadratic formula, and we get secant x equals to negative 1.303, or secant x equals to 2.303. So cosine x is actually negative 0.7675, or the cosine x equals to 0.4342, which is 1 over 2.303. So we get the reference angle for the cosine x here, and cosine x is negative on quadrant S and T, so second quadrant and third quadrant. So 180 minus 39.87, we get 140.13 degree. And quadrant 3, 180 plus 39.87 degree, we have 219.87 degree. While cosine x equals to positive 0.4342, our reference angle will be 64.27 degree, and cosine is positive in quadrant 1 and quadrant 4. So quadrant 1 will just take 64.27 degree, and quadrant 4 will be 360 degree minus 64.27, which is 295.73 degree. So we combine all these four values, we get 64.27 degree, 140.13 degree, 219.87 degree, and 295.73 degree. C. 3 sine x plus 4 cosine x equals to 0. So we find two different functions here. We try to move the 4 cosine x into right hand side, become negative 4 cosine x. So we know that sine x over cosine x will be tangent x. Therefore, we move the cosine x to the right hand side, to the left hand side to be divided, and then the 3 will move to the right hand side, be divided by 4. So we get tangent x equals to negative 4 over 3, where the reference angle will be 53.13, and tangent will be negative on quadrant 2 and quadrant 4. Put in the reference angle of 53.13, which is sticking to the x-axis, and we get the angle for x is 126.87 degree and 306.87 degree. Question number 2. Given that A is from 0 to pi, solve each of the following equations. A. Sine 2a equals to sine 4a. So sine 2a equals to sine 4a. The 4a is double angle of 2a. So we can expand this with double angle formula. Sine 2a equals to 2 sine 2a cos 2a. So we have common factor here, but don't rush for cutting it, alright? So we move everything to the right so that we have an equation that equals to 0. So we have sine 2a can be factorized with 2 cosine 2a minus 1. So the first factor equals to 0, or the second factor equals to 0, we get sine 2a equals to 0 or 2 cosine 2a equals to 0. So before we get the answer for 2a, we check on the domain. The domain given, the a, is from 0 to pi. So when we are solving for 2a, we need to make the domain into 2a. Alright, so we times 2 for the 0 and pi. We get 2a is from 0 to 2 pi. Therefore, sine 2a equals to 0. Our 2a should be 0, pi, and 2 pi. Where this you can get from the graph of sine. For 2 cosine 2a minus 1 equals to 0, our cosine 2a equals to 1 over 2. And the 2a is in the domain of 0 to 2 pi. Therefore, the reference angle for 2a is pi over 3, and we put the pi over 3 into quadrant 1 and quadrant 4, so that cosine will be positive. So 2a equals to pi over 3 and 5 pi over 3. So a equals to pi over 6 and 5 pi over 6, where we divided by 2 for pi over 3 and 5 pi over 3. So with the two sets of solutions here, we combine it and arrange in ascending order. We get a equals to 0, pi over 6, pi over 2, 5 pi over 6, and pi. B. 5 cotangent square of a minus 4 cotangent a equals to 0. So we factorize out the cotangent. We get cotangent a times 5 cotangent a minus 4 equals to 0. So we get the first solution, cotangent a equals to 0, which is tangent a equals to 1 over 0. This is special. Alright, we know tangent a will be equals to undefined when it is on pi over 2 and 3 pi over 2. But because our a is only from 0 to pi, so the only answer here will be pi over 2. Next, cotangent a equals to 4 over 5. So tangent a is the flip of 4 over 5, where we get 5 over 4. Reference angle for a will be 51.34 degree, which is 0.2852 pi. So the a is only in first quadrant for the a from 0 to pi. Therefore, we have only one answer here. So combine the two solutions here. We get a equals to 0.2852 pi, and I change the pi over 2 into 0.5 pi so that it look uniform in my answer. We have decimal place and pi, and decimal with pi. Next, question number 3. Show that tangent theta plus cotangent theta equals to secant theta cosecant theta. Then solve the equation of secant theta cosecant theta equals to 4 cotangent theta for the x from 0 to 360 degree. So from the left hand side of tangent theta plus cotangent theta equals to secant theta cosecant theta, we change the tangent theta into sine theta over cos theta, and the cotangent theta into cosine theta over sine theta. And we make the denominator same. So we times sine theta for the first fraction, sine theta. So we get sine square theta over sine theta cos theta. And we times cosine theta on the second fraction, so that we get cosine square theta over sine theta cos theta. Alright, then use our basic identity. We know that sine square theta plus cos square theta equals to 1. Therefore, we have 1 over sine theta cosine theta, which is 1 over sine theta cosecant theta times 1 over cosine theta, which is secant theta. So we get exactly the same as the right hand side. So proven. Then we need to solve the equation of secant theta cosecant theta equals to 4 cotangent theta. Okay, since we already proved that the tangent theta plus cotangent theta is actually the same as the secant theta times cosecant theta. So we can change the secant theta cosecant theta into tangent theta plus cotangent theta. Right? So we get tangent theta plus cotangent theta equals to 4 cotangent theta. Right? So we try to move the cotangent theta together. Okay, and we get tangent theta equals to 3 times of cotangent theta, where 3 cotangent theta is 3 over tangent theta. There, we times the tangent theta to the left, to both sides. Okay, so we have tangent square theta equals to 3. So our tangent theta will be plus and minus of sec 3. So for reference angle for tangent theta equals to sec 3, we have 60 degree. And then we'll put the 60 degree as the reference angle in all 4 quadrants, because it involves all the positive, negative. Therefore, we will get our answer theta equals to 60 degree, 120 degree, 240 degree in quadrant 3, and 300 degree in quadrant 4. Next, question number 4. If A, B, and C are angles in the triangle ABC, prove that A, sine B plus C equals to sine A. So before we do, we sketch out our triangle. Any triangle will do. And then label the angle with A, B, and C. Right? So now, with this triangle, and we ask to find sine B plus C. B plus C. So, which is actually 180 degree to minus the angle A. So we will get the sum of B plus C. Therefore, we will get sine B plus C equals to sine 180 minus A. And if we expand with the addition formula, sine 180 degree cosine A minus cosine 180 sine A, we will get 0 times cosine A minus negative 1 times sine A, which is sine A. So we get what we want, proven. B, cosine B plus C equals to negative cosine A. Same thing, B plus C is 180 minus A. So we are looking for cosine 180 minus A. So expand it with the addition formula for cosine. We get cosine 180 cosine A plus sine 180 sine A. So we get negative 1 times cosine A plus 0 times sine A. And we get negative cosine A. So exactly the same as the right hand side. So proven. Question number 5. The diagram on the right shows a trapezium of ABC. The side AB is parallel to DC and the angle of BCD is theta. Find the value of each of the following. A, cosine theta. So theta is here. This is a second quadrant angle. And from the two parallel lines, we know that theta can be also here. We have alternate angle. So if this is theta and the green one is the reference angle of theta, so which is 180 degree minus the original theta, and we will get the reference angle. So we can use this reference angle to find all the values for the trigonometric function that we want. A, cosine theta, right? So we try to build our right angle triangle here, okay, and put in the axis, the x-axis and y-axis. Alright, so we will have hypotenuse of 17, and then we have opposite of 15, and this should be 18 minus 10, which is 8. Then the negative here because it is on the left of our Cartesian plane. Alright, so we have cosine theta is actually negative 8 over 17. Because of the second quadrant, cosine in second quadrant will get a negative values. So you can actually base on here, negative 8 over 17, or you get a positive 8 of the length here. The length here is positive 8 and the length here is 17. If we use the ratio of the length, will be 8 over 17. But cosine theta, theta is in second quadrant. So we need to add a negative here. Alright, so either way, you should get your cosine theta equals to negative 8 over 17. B, sine 2 theta. So we expand with double angle formula. We get 2 sine theta cosine theta, where 2 sine theta is opposite over adjacent. cosine theta, where we can get values from here. So we get negative 240 divided by 289. C. Tangent 2 theta. So tangent 2 theta can be expanded by 2 tangent theta over 1 minus tangent square theta. So 2 tangent theta, which is opposite over adjacent, divided by 1 minus 15 over negative 8 square. So we get 240 over 161. Then determine the value of theta. So we choose the simplest one. So we choose from cosine theta. Cosine theta equals to negative 18 over 17. So the reference angle will be 61.93. Since we know that theta is in second quadrant, right? So theta will be 180 to minus 61.93, and we get theta equals to 118.7 degree, 0.07 degree. Question number 6. An electric pole is reinforced by 2 cables as shown in the diagram on the right. It is given that the height of the pole AB equals to 24 meter, distance BC equals to 7 meter, angle BAC equals to theta, and angle ADB equals to 30 degree. A. Without finding the angle CAD, calculate the value of sine angle CAD, cosine angle CAD, and tangent angle CAD. So angle CAD is here, okay, which we know that this is 180 to minus, this is 90 plus theta, because it is 180, okay, minus this place. Alright, so we get 90 plus theta here, okay, and then minus the 30 here, we get the angle CAD. So we actually know that angle CAD is 60 minus theta, but we don't know theta. Alright, we need to find the angle of the value of sine angle CAD. So by expanding the addition formulae of sine, okay, sine angle CAD is actually sine 60 minus theta. Alright, so expand it with sine 60 cosine theta minus cosine 60 sine theta. We get sine 60, which is 3 over 2. Cosine theta, theta is here, and the cosine is 24 over 25. Then cosine 60 degree, which is 1 over 2, sine theta will be 7 over 25. Okay, so we get the 25 from the Pythagoras theorem because of the right angle here. So simplify it, we get 24 sub 3 minus 7 divided by 50. And then cosine angle CAD, same thing, we change the angle CAD with 60 minus theta. And then expand the whole thing with addition formulae. So cosine 60 times cosine theta plus sine 60 sine theta. So cosine 60 is 1 over 2, cosine theta is 24 over 25, sine 60 degree is 3 over 2, and the sine theta will be 7 over 25. So expand it and simplify it, we get 24 plus 7 sub 3 over 50. Then tangent of angle CAD. So tangent of angle CAD, we can just use sine over cosine. Okay, sine angle CAD over cosine angle CAD. So that we know we get 24 sub 3 minus 7 over 50 divided by 24 plus 7 sub 3 over 50. We get these two values substitute inside. And with the same denominator, we can cut off the 50. So we get 24 sub 3 minus 7 over 24 plus 7 sub 3. Then I will times 24 minus 7 sub 3, which is the conjugate of 24 plus 7 sub 3. So that I will make the denominator in rational number. So we will get 576 sub 3 minus 504, and then minus 168 plus 49 sub 3 over 429. So simplify everything, you get 625 sub 3 minus 672 over 429. Next, B, state the length of two cables. So the two cables involved is AC and AD. So AC is clearer. We can get it from the Pythagoras theorem, which is the surd of 7 square plus 24 square. So we get 25 meter. And then the length of cable AD, okay, so from the big triangle ABD, the right angle triangle ABD, we know that 30 degree is actually formed by AB and then BD and cable AD. So we need to find cable AD. We can use sine 30 degree equals to opposite over hypotenuse, which is AB over AD. So sine 30 degree is 1 over 2. AB is 24 meter. Therefore, AD is actually 48 meter. Number 7. The diagram on the right shows a triangle PQR with the side P, Q, and R respectively, and the corresponding opposite angles theta, beta, and alpha. Show that the area of the triangle is given by the following formula: L equals to P square sine beta sine alpha over 2 sine beta plus alpha. So, firstly, to relate all the sides, we can see only P square here, alright, with the 3 sides R and Q. So we try to relate all the sides with P, alright. So we can think of sine rule to apply in any triangles PQR like this, alright. We know that side P over sine theta will equals to side Q over sine beta and will also equals to R over sine alpha. This is how we get from sine rule. And we know that theta, okay, because this formula only involve alpha and beta, so theta is actually 180 degree, okay, the sum of interior angle 180 degree and minus the sum of alpha plus beta. So sine theta is actually sine 180 minus alpha plus beta, where we get only sine alpha plus beta. Alright, so with this concept, we sub into the sine rule. When we have sine theta, we change it into sine alpha plus beta. And then we compare the first two, we get Q equals to P times of sine beta over sine alpha plus beta. And then to compare the second pair, we get R equals to P times of sine alpha divided by sine alpha plus beta. Alright, and we know the area of the triangle should be equals to 1 over 2 times base times height. So I try to build my height px here. Alright, and with any angle, let's say I use alpha, okay, it is equals to this small triangle opposite over hypotenuse, which is the px over q. So px is actually q times of sine alpha, where the q can be changed with p sine beta. So p sine beta times with sine alpha, p times p sine beta over sine alpha plus beta times with the sine alpha here, we get p sine alpha sine beta over sine alpha plus beta. That is the px, so the base, the height. Okay. So come back to our formula of 1 over 2 times base times height. We have 1 over 2 times base, which is p, times height, which is what we get here. So we get L is actually equals to p square times sine beta sine alpha over 2 times of sine alpha plus beta. That is what we asked to prove and proven. Number 8. Given that secant theta equals to t, where theta is from 0 to pi over 2. Find the value of each of the following in terms of t. A. Sine theta. So we can sketch the triangle before finding anything. Okay, with the second theta equals to t, which is hypotenuse over adjacent, 1 over cosine, right? So hypotenuse is t and the adjacent is 1. That's how we get our t and 1. Alright, and we'll get the third side, which is the opposite of the theta, of third t square minus 1. So from this triangle, we can easily find sine theta, which is opposite third t square minus 1 over the hypotenuse t. There we get this answer. B. Cosine pi over 2 plus theta. Alright, so we know that cosine pi over 2 minus an angle will be equals to sine that angle. Alright, so we use this cosine pi over 2 to change positive into negative. So we break the positive into minus negative theta. So we now have sine negative theta. So sine negative theta can be simplified with negative sine theta. So we know that cosine pi over 2 plus theta is actually negative pi third t square minus 1 over t. C. Tangent pi minus theta. So we expand this with addition formulae. So we get tangent pi minus tangent theta over 1 plus tangent pi tangent theta. So we get 0 minus third of tangent t square minus 1 divided by 1 plus 0 times third of t square minus 1. So we get negative third of t square minus 1. Number 9. Sketch the graph of function fx equals to 1 plus modulus cosine x for the domain of x from 0 to 2 pi. A. State the range of the corresponding to the domain. State the range that corresponds to the domain. And then B. Then, by sketching suitable graph on the same axis, state the number of solutions for x times modulus cosine x equals to 1 minus x. So we need to sketch the graph for this function. Alright, so first we will sketch out the cosine x, which is a V-shaped curve from 0 to 2 pi. Alright, and then with the modulus, we flip wherever below the x-axis become positive. So we get this. Okay, next, the whole graph of this will be plus 1. So we will be shift up 1 unit above. So instead of y equals to 0, now become y equals to 1. From the maximum 1 just now become 2. Therefore, we have our graph like this. The 1 as the reference x-axis, and we will have exactly graph of modulus cosine x. Alright, so this is the complete graph for fx equals to 1 plus modulus cosine x. A. The range that corresponding to the domain. So the range here, we are talking about the fx is covered by 1 and 2, right? So the fx is from 1 to 2. Then B. By sketching the suitable graph on the same axis, state the number of solutions for the x modulus cosine x equals to 1 minus x. So we try to solve this, okay, and we try to get back 1 plus modulus cosine x. So we move the negative x to the left hand side so that we get x plus x times of cosine x equals to 1. Factorize out the x, we get 1 plus modulus cosine x. So now this is actually our fx and the graph we have drawn just now. Alright, therefore we move the x to the right hand side, become divide. So we have 1 plus modulus cosine x equals to 1 over x. The fx equals to 1 over x. So be careful. 1 over x is actually a reciprocal function, which is a curve. Alright, so when we build a table to draw the curve, we need more than 2 points. We need more points, right? So we can choose any of the x value and then find their corresponding y values. Okay, and we have 1, 2, 3, 4. And we know that the nearer the x getting to 0, okay, then the higher value of the fx will be. So we know our reciprocal graph will be this way. Then state the number of solutions for this equation. So we need to find the intersection point between our graph fx and the 1 over x. Therefore, we find only one solution or one intersection point here. So final answer will be only one solution. Thank you.